Sorry guys, we got cut off, but I'd like to continue from this point. And still on part 2, I'll ask my reviewer to combine the 2 videos. Apologies about that. So because you can choose X, you have the power to choose X. You have the freedom, actually. Let's not use the word power. I don't want you to confuse it with the power here. Right? Because you still remember that despite that deletion, you still remember that this is the base. That's why I chose B, actually, so that it triggers your memory. Here I didn't have to choose B. So tomorrow, even if I choose Y here or Z, you will recognize it as the base because of the power. And you can distinguish the multiply. Well, in this case, because I said X is the multiply, remember when it was formed. After the commutative law, I never specified which one is the multiply. Well, in this case, the B is the multiply of X. It's the one that multiplies. It will be telling X how many times we must add X. So say B was 3, as it was 3 before we deleted it. Then it means X plus X plus X. Meaning I can write the statement with this sign. If B was 3, this would mean X plus X plus X. Never mind the way I write X different. They are the same X. What I'm worried about is that the multiply is also X. How do you distinguish between X and this multiply, which is also X? Because some people write like only they write X this way. So we'll have to correct that. We'll have to correct the notation. But for now, rely on colors that the multiply is the operator. And this is the multiplicand. It acts as a multiplicand. It still means the same statement here. But here it. So if B was 3, this statement would read X plus X plus X. Because B acts as a multiplier. Now, because the 2 statements are equivalent, you can say, but if it's a multiplier here, what is it here? That's why we refer them as factors in general. But B and X are factors. So that because the commutative law will throw your names out. In one case, X will be the multiplier, and then it becomes the multiplicand, the commutative law. So we say they are factors, meaning this is in a factorized form. So is this. These are, I'm stating them because in case you get thrown into that confusion where you say, well, how am I supposed to think about this? To say, no, you're still thinking correctly. But you're trying to explain logically what happened because you don't want to lose the name of somebody. It's like your name. If you go to your friend, you don't lose your name. You want to keep your name. So you'll be thinking correctly that X is a multiplier, but you say, but this is the one that multiplies. So we drop the multiplier name. We literally drop it so that it doesn't create confusion. And we call these guys factors. So it doesn't matter which one. This is a factor, this is a factor. So even if you swap them around, they're still factors. You understand? But indeed, this will be the multiplier and this will be the multiplier if you want to insist on keeping those names. Now, because I don't know what X is, I can't write this statement anymore. And of course, I can continue to use the equal sign because I can choose a relational symbol. Because I don't know what X is, I don't know what this, I can't write this expression. So what am I supposed to relate this with and this with? Now pick a guess. Take a very intelligent guess. What you are going to pick is going to be your first, what should I call it? I need to give it a very beautiful name. Your first tool, if I can use that. It's going to be your first present with which you are going to enter into mathematics. All along, we've been doing algebra and arithmetic. By the way, all of this is called algebra. Some people classify this as algebra. All of this, A, B, and C. Some people can even be particular. That's why we have vector algebra. This is just algebra, all of it. I present it to you this way so that you can see how things evolved, where things come from, because of the symbolization. Remember, we are addressing challenges that were raised by peer review paper, one of which is Peter Oyo from Kenya. And at the same time, bringing more peer-reviewed and primary material to explain concepts or explain or remove confusion that was created, like in the case of the equal sign, where we state Sarah Powell from the University of Virginia, 2012, who points at the problem originating from textbooks in the misuse of this symbol, the equal sign, tying nicely with what Peter Oyo's investigation. Very beautiful. You may even think that maybe, I may even think that at one point they did communicate. They could have written the paper. They could have communicated, of course. Why not? That's for you, because both papers give reference. So you're encouraged to read those papers, even at an early age. Even if you are in grade 6 or grade 4, you're encouraged to read those papers. Now let's be logical about the whole thing, mathematically logical. Right? To say, okay, B is fixed. I just come with it once, like 3. And then I choose what to do with 3. I say, okay, I want to add it to itself, or I want to multiply it by itself so many number of times. But this time, the so many number of times is held by this guy called X. So let me create a little bit of space here. You already understand the commutative law. This was just explaining the commutative law, so that you don't confuse this part from this part, the exponential from the factorized. But whatever we're going to do is going to be the same. You don't come, maybe you can think of that you'll get 2 different explanations. But let's think logically, all of us. You say, oh, you came with a number B. We call it B now because we don't want to say 3. Right? So we say B. And we want to add B to itself X number of times. See the statement? Or yeah, we come with B and we want to multiply it by itself X number of times. That's what exactly these expressions are saying, respectively. But now when you do that, and you see the addition of B by itself, you're invoking arithmetic because you are seeing it. Or if you are seeing it as multiplication, you are still invoking arithmetic. And these are operations. These symbols are saying you have to calculate. So you have to do that calculation. If you're seeing plus here as B plus B plus B X number of times, you have to do the plus. If you see 2 plus 2, you have to do 2 plus 2 and come with the answer according to that operator. If you're seeing 2 times 3, you have to perform that because times is an operator. It says calculate. And you come with an answer. You're the one who came with an answer because you operated, not the equal sign. Okay? Good. Now, that's all you have to realize for now. So you pack it aside, that logic. Say, okay, I understand. You're still doing the same thing. Right? But now we're going to do something else. We are going to give these expressions names. And we are going to call them functions. And we are going to use the letter F for functions. We are going to say, this is a function, and this is a function. And in particular, it's a function of your choice. Of your choice. This, I'm consistently using F, but they don't have to be F. But I'm not complicating things now. So what does it mean to say? What does this mean? It says you have an expression which relies on your choice, yours, on your freedom to choose. And it tells you what represents that freedom. So we're still following colors. When you start having a freedom to choose, now we see something else happening. But then comes another thing to say, but remember the thing that we parked aside and said, oh, if I come with a number, say 3, this will mean B times 3, which means B plus B plus B. So I must do the operation, whether I see it as B plus B plus B or B times 3, whatever B is. The operator tells me I must perform an operation. But that is going to come, that operation is going to come with an answer. It's going to come with another number. By virtue of the operator, 2 plus 3 is 5. Not because of the equal sign, because of the plus. Okay? So when you choose a number, whichever one that you want, well, you're telling B to add itself so many number of times. Or you're saying, I'm going to multiply B by that number. So the times takes over and performs the arithmetic, the calculation, the arithmetic, and it comes with another number. This f of x, we say f of x, we're just saying that, oh, now we've got an expression in terms of your choice. That's all we're saying. Yeah. You say there is something which depends on your choice. And we state the dependent. Well, it's called independent variable. It can vary, you can choose it. But this expression depends on this variable, your choice. It represents strictly your choice. How many ice creams do you want? That's X, Baba. Right? But that, unfortunately, or fortunately, is going to invoke arithmetic, either this or that. And arithmetic is saying it's going to do a calculation and come with an answer. Now we need to find, what do we do with that answer? Do we throw it in the, what do we do with it? Well, we give it to something else, which we call y. In both cases, when arithmetic has done the calculation, that which it comes up with, we give it to y. So y doesn't come from anywhere else. It comes strictly from your choice. You choose, arithmetic takes over, does the calculation, produces a number based on the operator, and then that number that it produces, we give it to y. Now we need a way of associating your choice with that result that came as a result of the operations that were applied after making your choice. And the connection is this guy. Remember, this guy represents that, oh, now there is something that depends on your choice. That's all this guy is saying. This guy. There is something. The expression, on the other hand, the expression is in terms of your choice. It depends on your choice. Now we need to link this literally to this. Literally. This is still the equal sign, right? This is still a relational. I'm using the equal sign as a relation. Could have used any of those. But now I want to write it nicely. Right? I want to write it nicely. I say I don't have to have a very long thing. All I have to do is to say this one is f of x. This one will be related by whatever relation I choose, relational symbol I choose. F of x. We're halfway there. Actually, we're 99% there. Can you follow the logic? The result that the operator is going to produce after you made a choice is going to be given to y. Now we need to tell ourselves that this y is not something that we pulled out of thin air. It's related to what was called the function, a representation of an expression in terms of your choice. So now, because I've been writing backwards, right? When you read it, it says y is a function of x. But you're going to ask a question, what is a function of x? Well, I'm going to tell you. Well, a function of x is an expression in terms of your choice. You see, I'm playing with words. Where f of x is an expression in terms of your choice. Now we can say, oh, this y is related exponentially to your choice. Or this y is related linearly. You see a line? See, I'm throwing you with another word. Say, but factorize, there's no word like that, right? It's linear. So where does that word come from? Well, put it aside. Because the only word you've got is factorize. Here you are lucky to see exponential. Hence, you don't have a problem with exponential. But there was no inference to the word line before in introduction part 1 and even first part, the beginning of part 2 up to now. I have to do that. It's called a wildcard. Just throw a wildcard at you. Say, well, line, maybe. Well, maybe you see something. Others do, others don't. Well, if you think you've got it, show it to the next person. Why I'm saying line. L-I-N-E. Line. Like a line. Like a straight line. Yes, that line. Explain it to somebody if you think you've got it. And all of you will get it anyway. It's called a wild card. Just throwing a wild card at you to jiggle you up a little bit. Now, before I go to that line thing, I have to do something now so that the confusion is not caused. Because I'm going to stop using colors. And you need to figure out what the operator is. Well, in this case, we just drop this guy. And it reads bx. When you don't see an operator, it means multiply. Some people put a dot here, but the dot is preserved for vectors. It also means product. It also means multiply, but for vectors. So there's nothing wrong in putting it here, but we do, and we write it nicely as bx. So because there are two symbols, it's not like 21 or 2 and 1, which can be read 21. It's two symbols, meaning they are multiplying each other. You're not used to writing, if this is 3, if this is 4, you will think that it's 34. No, it's literally 3 times 4, if you don't see the symbol. Remember, this was a number that you came with, and you say, I want to do something with itself. Either I want to add it to itself X number of times, right? So we can change this. It's an arbitrary number, and call it M. And M. Of course, I'm saying M, comma, B. I'm stating numbers as elements of the real, so that I don't write M element of the real, B element. No, it's one. It means the same thing. I'm saying M and B are element of the real. And then I do the cruel thing. And then I add something. And I say C is the element of the real. Now some people which are in grade 11 will start recognizing this expression as the line. For those who are young, ask the grade 11, 10, 9, 10, 11, 12. You need to learn to work as a team now. Each one teach one. It's beautiful. If you really think you know or understand something, try to teach it to somebody else, especially a young one. Right. Are you still on the line? Do you see an arithmetic series? Right here. Yes, I said series, sequences and series. I didn't bite my tongue. Do you see it? Do you see a geometric series here? Do you see simple interest here? No, I didn't bite my tongue. Simple interest. Yes, in finance. Do you see compound interest here? Well, this is the end of part 2. And this is the most powerful thing now that you have entered. That's what I mean by you are coming to maths with a present. This is your present, the function. Because now we're going to do a lot of other things with a function. Let me state a few, just 2. We're going to do inverse functions. This pen is not visible. Inverse function. We're going to do calculus. And in this calculus, we're going to do both integral and differential calculus. We are going to do linear programming. You're going to be an expert in drawing graphs. We're going to draw graphs. I'm running up. Let me see if you can see this. We are going to do graphs. Because you've got a function, we are going to do rational expressions and functions and equations, polynomials. Welcome. I told you, you've got a present now. This guy. Rewind as much as you can to listen to that logic. You want me to repeat it now? I'll repeat it. Because that logic is that which you actually were waiting on the door with a present called functions. And you want to enter the room of mathematics. Welcome. Because now you're going to do all of mathematics. Tensor calculus. Wow. Sequences and series. Yo. I wish I had a list here. Sometimes I write them somewhere. You are going to do trigonometry because you've got functions. What is a function? A function is a relation. What is that which relate? What is it relating? Your choice. Exactly your choice. Your free choice. Your independent free choice. To what mathematics produces represented by y. Your choice to y. This is produced by arithmetic. This. Nothing else. Now you will bow down to arithmetic and say, wow. You will literally bow down to mathematics. You won't just come in and say 2 plus 2 is 4. You will bow down to this guy. And he has an ancestor called counting. You think I'm joking? Go back to your history book. There's a video done by a historian. Go there. And learn how ancient blacks from 3,000 years before Christ was born, more than 3,000 years, teaching you how to do what we are doing. You will respect the elders. Now you will go to school and say, I want to find out more, which means you want to do research. Because there's a lot that we still don't know. These are the people who built pyramids. Build me one, build me one. Just one, just one. One. Not 100, one. Good luck. You deserve it. You will deserve it. And don't forget to align those pyramids that you are building with the stars for some funny reason. The stars, yes, Dinaledi. Like I said, you will deserve it. Good luck. Your ancient black ancestors. Washo ugogo wami uMakhuzu sentabeni namagqomo ngaphezulu wathi basop platform 1. Badlali ngenkulumo yabantu abadala. Skaba abathoma babhala kapuwa yabathu abaholo ndati. Let the ancestors speak. There. Not me, not this historian. Themselves. Let them speak. They will teach you better mathematics than I can. Really. I'm scared where I am. I'm shaking. I'm quivering with fear. You will venture into archaeology. There is a shortage there of archaeologists. There are careers and careers waiting for you, my guys. Careers and careers. You will enter into geology. You will enter into paleontology. You will enter. Physics and maths is not the only thing. Engineering is not the only thing. It's required. We need engineers. We need scientists. We need everyone. You will go into. We need molecular biologists. They're waiting for you. Those careers. Waiting. And you still want to go to school to get a job. Well, let's play with rational expressions. Let's play with graphs. Let's play with inverse functions, calculus, linear programming, tensor calculus, which will take us to relativity, special and general relativity, quantum physics. We need everyone. Everyone. Because you have entered here. Now, for interest's sake, what if you had more than one choice? What if you had more than one choice? Well, what is the other choice? Maybe this could be a choice of water, that you choose to come with 2 liters. But water is not everything, right? It is everything, really, but we need something else. And you say, no, I want to also have, where's the red pen? Oh, there it is. I also want to have another choice called y, which is different from x. Right? Well, I'm just using it here. You will have to tell me, well, mathematics, and say comma, y. These are your independent choices. We're just specifying one as an introduction. B is what you come up once, and you choose what to do with it. And your choice is now controlled by, well, in this case, x, in this case, x and y. Well, if you have used the y here, well, what about this y? You'll have to change it and say z. Because it is calculated by an arithmetic. So this is x and y. F of x is telling us what your choices are, independent choices are. That there is an expression in terms of your independent choices. And it's specifying those independent choices. In this case, it says it's only x. In this case, it says your independent choices it's x and y. But the arithmetic takes over. Does whatever arithmetic does. Give a number, produce a number, and we give it to this. Hence, we associate this, what arithmetic produced, right? Using that relation. Hence, the relation relates your choices to what arithmetic produces. Welcome. You're going to say it in many ways. Now you are ready now. We'll probably come here and here, here and here. Graphs in part 3. This is not part 3. This is part 3, not this. Sorry about this. I forgot to change it. I usually forget. What we are doing is part 3. Or I should have said part 2 continued. Oh God. Gap. But anyway,